this example using the exactly same setting of null, host, rules, and our graph. I have already dropped the graph, and now I will recreate the graph. I want to evaluate the idea that in order for what problem to be an answered question, it must have this has selected option. See if we just change it to has option, and SD is an answer. Let's see what's going to happen with the inference. My expectation is that the word problem will no longer be classified as an answered question, even though it does has option SD and SD is answer, because I did not say that has option implies that word problem also has selected option. So has option is not a super property of has selected option. At least I didn't say that. So if we run that, the graph going to be created, and now I can query its type. Yeah, so that's correct. As I had expected, the system did not infer that what problem is actually a answered question. So it is important, very important to know that some value from restriction implies that property must exist. So we already demonstrate that. Let's see. And the second criteria is, and that some value must come from this class. So let's try out the second idea. So I'm meeting the first requirement, but this time I'm going to call ST a solution. And I did not say solution is a subclass of answer. So I again expect the system do not infer what problem is an answered question, because we did not meet the second criteria that some value of has selected option must be an answer. So again, let's drop the graph and then recreate a fresh graph, and then we can query this. Again, the system cannot infer what type, what problem is. So that confirms the two conditions. If you define a restriction using some value from, for a instance to meet this restriction, the instance or the individual must have this property, and some value, at least one value for that property, must coming from this specified class.